Not every day you get to talk to an astronomer at Yale who can talk about the music that stars make. And so let's get right to it. My guest is Dr. Earl Bellinger, assistant professor in the Department of Astronomy at Yale. Welcome.
Thank you.
I can't wait to pick your brain. All right, I'm going to set the stage here. You're a musician with a recording studio. You play a ton of instruments and write songs. You love computers and programming and have traveled the world using math to look at stars. Where did this fascination come from?
As a kid, I just loved learning about math and programming. It was those aspects that drew me. It was only when I was a senior in high school that I started to get interested in physics, because I realized that it was a language that we could describe the world around us. And then when I went to college, I got to meet an astronomer, and he kind of pulled me into this world, and everything's been different since then.
All right, tell me about the music that stars make. What do you mean by that? Basically in layman's terms, if you can.
Well, I'm so glad you asked. So I work on pulsating stars, and what most people don't realize is that pretty much every star is a pulsating star, including our own sun. And inside of these stars, there are acoustic waves. They're sound waves. And so stars are making music for us. And we can see that in their brightness changing. Sometimes it's very subtle. Like in the case of the sun, we didn't discover that it was making these songs for us until the 1960s. That's how subtly the surface of the sun is moving due to the music that it makes. But there's some stars that are pulsating so dramatically that we can see them performing their dance all the way in distant galaxies.
How do we see this, and what applications might this have to us on Earth?
Yeah, absolutely. Well, we see it in their starlight. So stars aren't constant when you look at them. They're changing in brightness over time. Some of them are changing very rapidly in brightness. A star like the sun, the typical period of its pulsations is 5 minutes. And so it's doing this very complicated dance where if you can observe the star very precisely, more frequently than 5 minutes, then you can see the starlight bopping up and down. And you can look at a frequency spectrum just like we do with music and understand the different frequencies with which the star is pulsating. Now, this teaches us a lot of different things. We can look inside of the stars using this. Just like earthquakes reveal the structure of the Earth, starquakes reveal the inner structure of the sun and of other stars. And one thing that's interesting is, this teaches us about the speed of sound inside of stars. Now, there's a cool party trick. If you go to a party and you inhale a helium balloon, you change the pitch of your voice. And why is that? That's because you change the speed of sound inside of your throat. Well, in stars, they're fusing hydrogen together in their cores through nuclear fusion to create helium. They're changing the amount of helium that's inside the star. They're changing the speed of sound. That changes the kind of instrument that's being played, and so from that we can look inside of the star and figure out how old it is.
How old are stars?
Well, they span a variety of ages. Our star is 4.5 billion years old. The earliest stars are probably around 12 or 13 billion years old. And we're trying to collect this information about stars to put together a picture of how old the stars in our galaxy are, because if we can combine that information with their orbits and their chemistry, then we can put together a story of how the galaxy formed and how it evolved over time.
All right, now I get that. I get that now. You're a musician. You have a recording studio as well, talking about stars and music. You write music, there are no words to them. Are you ever planning to do that? And you've written how many songs?
Well, quite a number over the years. Yeah, I'm not necessarily looking to add lyrics. Maybe it's possible, but I truly love the art form of instrumental rock and post-rock. It's not for everybody. Some people can only connect with music if there's lyrics, but it's truly, I think, a wonderful art form all on its own.
How does the general public get a hold of you if they want to learn more about the music, the pulsating that stars do? Because I know you're a professor at Yale, but this is a fascinating topic that I don't think most people have thought of.
Yeah, sure. Well, I have a website, earlbellinger.com. I also have a website for my group, the Yale Astro Machine Learning Group, or YAML for short, so you can learn about the kind of work that we're doing in the Department of Astronomy.
I appreciate you being here so much, just giving me a little taste of what it is that you're doing.
Well, thank you so much.
You bet. And for more on astronomist Dr. Earl Bellinger, go to WTNH.com or the News 8 app.